right, I guess we can go ahead and get started. Hello, everyone, and welcome to today's panel. This panel is put together by the Purdue Student Chapter of the Institute of Transportation Engineers and the Aspire Student Association. Our panelists will be talking about pavement electrification. In that, they will answer questions pertaining to the cost and benefits of this technology, ongoing research on the topic, and policy implications of the implementation of such technology. We will begin by having introductions and logistics, talking briefly about how we want you to ask questions and how the questions will be asked to the panelists. We will follow that by some prepared questions to the panelists and then open the floor for the audience to ask questions to the panelists. Eventually, in the last 15 minutes, we will have wrap-ups and final remarks. Please note that this session is being recorded. I will be one of two moderators for today's session. My name is Abdullah Nafak, a second-year PhD student in transportation engineering here at Purdue University. And I have with me Ali. If you may please, Ali, unmute and introduce yourself.
Yeah, hi everyone. I am currently an MBA candidate at the University of Washington, but I did graduate from Purdue in construction engineering and management in 2014.
Thank you, Ali. And as may the audience already notice, all the audience are muted. We will allow the audience to unmute and ask questions when it's time for the Q&A session. And if you face any technical difficulties throughout the session, please indicate that in the chat box and our team will assist you. When it's time for the Q&A session, we ask the audience to please use the raise hand feature to ask your questions. Once your hand is raised, one of the two moderators will call on your name, you will unmute and ask your question. With that, I am pleased to introduce to you today's panelists, starting with Professor John Haddock. John Haddock is a registered professional engineer and a professor of civil engineering at Purdue University, where he also serves as the director of the Indiana Local Technical Assistance Program, LTAP. Prior to joining the Purdue faculty, Dr. Haddock worked in private industry as a pavement engineer, as a senior research associate for the National Center for Asphalt Technology, as a research engineer for the Indiana Department of Transportation, and as a district engineer for the Asphalt Institute. During his career, he has worked in research, equipment, and test method development, and criteria and specification writing. He has been responsible for asphalt mixture design production, forensic pavement investigation, and pavement design and analysis. Dr. Haddock is a member of the American Society of Civil Engineers, ASTM International, the International Society for Asphalt Pavements, and the Association for Asphalt Paving Technologies. He has served on several Transportation Research Board committees and is the past chair of AFK 30, Committee on the Characteristics of Non-Asphalt Components of Asphalt Paving Mixtures. He currently serves as a member of TRB Committee AKM 10, Standing Committee on Production and Use of Asphalt. Dr. Haddock is the co-editor-in-chief of the ASTM International Journal, Advances in Civil Engineering Materials. And I will hand it over to Ali to introduce our next two panelists.
Yes, I'm happy to introduce you to Pavement Jikar. He is currently a civil engineering graduate student at the University of Texas at El Paso, UTEP, I think is what you call it. He is also currently a graduate research associate at the Center of Transportation Infrastructure Systems, which is the research center that generates and shares knowledge in different aspects of transportation infrastructure at UTEP. Prior to joining UTEP, he was working for almost 3 years as a deputy engineer highways division at one of the sought-after consulting firms, serving in engineering and planning sectors with projects spread over Asia and Africa. With the objective of a sustainable future for all, he's currently working on a, I think it's a Texas DOT funded project to improve the durability and longevity of the asphalt pavements, both in rutting and cracking failure, using high quantities of recycled asphalt pavements, while coming up with the specifications to build performance engineered roads for the future, also known as a balanced mixed design. He has published a technical paper on calculation of carbon footprints for highway pavements and has also completed a Federal Highway Administration certification course on sustainable pavement systems. In his relaxation time, he likes to create wall paintings and loves hiking to connect with nature. He also holds a Bachelor's of Technology in Civil Engineering from the National Institute of Technology in India, and a Master's of Technology in Transportation Engineering, also from India. And our third panelist is Richard Young. He is the Vice President and Program Manager at AECOM. Richard Young is currently the program manager for the $4 billion reconstruction of the I-294 corridor for the Illinois Tollway. Prior to his current assignment for the Tollway, he was the program manager for the General Engineering Services contract for the Illinois Tollway, with engineering oversight on the $17 billion 15-year capital improvement program. Both programs involved innovative opportunities to build a transportation system for the future, including opportunities for static and dynamic wireless charging. Mr. Young earned his Bachelor of Science in Civil Engineering from the University of Iowa and his Master's of Business Administration from DePaul University. Thank you.
Great, and with that we can begin our questions. We will start with an open question to all three panelists. We're going to ask them to please describe to us pavement electrification in a nutshell.
Go ahead.
Who gets to start?
We'll start with you, Dr. Haddock, since you're asking the question.
Okay. So in a nutshell, it's basically putting chargers in the pavement so that vehicles, as they move down the roadway, can recharge their batteries dynamically as they move. That's what it means to me. There's also, obviously, you know, the ones that go in stationary locations as well. But I'm primarily focused on doing it dynamically on the roadway.
Yeah, I would agree with
Go ahead,
that. Yeah, I would agree with that. You know, what we were looking at here is, you know, on a tolling system that I'm working on, and, you know, to provide that not only for passenger vehicles, but for freight vehicles. We have heavy freight traffic, and then, you know, transit vehicles, buses that would run, you know, along our corridors on a dedicated lane, and how can we connect that not only with electrification, but autonomous and connected vehicles to transport, you know, people from where they work to where they live. You know, a lot of our corridors have disadvantaged locations, you know, and we're trying to get them to those work centers, being the airports in downtown Chicago. So that it's also, you know, a society and equitability and, you know, inclusion and all those things that go with it, that I think installing, you know, electrification of the roadways helps bridge that gap as well for those type of things.
Yeah, I agree to what Mr. Richard was saying. I think for me, EV is not only the infrastructure in the mechanical division, but also like in the physical infrastructure that we put together by electrification of roads, that is charging dynamically as well as stationary during when it is idle. So I think this one, like the present role of us, the civil engineers, is to integrate these two technologies to build dynamic roads in which they are smart in a way that they can be like the role models for the future technologies like automated vehicles and stuff that are coming up in the future. So I think this is like a stepping stone for it.
All right, thank you. We'll move on to the next question, which is for Dr. Haddock. And your question is, what do you think is the biggest obstacle to implementation of this technology, and how can we overcome it?
So I like this question because as I've been involved in this particular topic over the last few years, what I think is the biggest obstacle to get there, I think, is kind of changing. I've heard people say, look, our big obstacle may be electrical connections in the roadway, right? I mean, the roadway moves around not only under load, but under the environment. And that could be hard on the connections that you have to make electrically. So that may be one thing. Another thing that I've heard people say that seem to know is the thermal management. You know, if you have these charging systems in the road, they're going to generate heat. and the pavement's going to have to deal with that, or we're going to have to do something to the pavement to deal with that thermal problem that could actually occur. So that may be a big one. Although over the last year, as I've gotten talked more and more with the electrical engineers, I'm not so sure that the biggest problem that we're not going to have to overcome is if we're all going to drive electric cars, where are we going to get all the electricity? How are we going to generate all that electricity? We live in an era where I think the majority of people think that we should be moving to a clean energy, which for us tends to mean solar power or wind power. And those two can be problematic from time to time. The sun doesn't always shine. And as we learned in Texas in the past week or so, apparently the wind turbines don't always want to work or can be problematic. So the question is, I think we're going to have to determine where is all the electricity going to come from. If we're not going to burn natural gas to make electricity, then we're going to have to find a better source probably to electrify everything. And I don't mean that as a trying to throw a bucket of water on the parade, because I think this is doable. I think it's just something that is part of, I mean, Aspire works in that framework, right? With electric companies, with the companies that produce it. So I guess I think that may be one of the biggest problems. And I think we can overcome that by working closely with the power companies that produce the power and distribute it.
Great, thank you, Dr. Hajduk. I'm gonna follow here with another question. New technology is expensive. How can we justify implementing this tech without a large user base? Both DOTs doing construction projects and users purchasing AVs. And I will ask Rick to begin here.
Oh, okay. You know, and I want to follow up on Dr. Hajduk's comments. You know, if you would ask me, you know, it's money and planning too, you know, the implementation of it. So I think those are one of the challenges that we got to work on is, you know, for my project, it was how do we get that implemented into a project that takes 5 years from its inception to actual construction, and where does that fall into that? And also where can you get the implementation of the money from? And I say that because, you know, with COVID, I think that woke up a lot of our eyes. You know, we're in a different world now. And, you know, the primary purpose of a lot of the DOTs that Dr. Hajduk was talking about is to keep their roads maintained and open and fixed. And are they going to invest in this type of technology to move it forward? I think that's something that we also have to overcome is how do we get there and how do we bring that to them, to these agencies in a way that they can implement it and that they can scale so that we do see these returns on that investment. You know, putting in the static chargers at locations, I think is great and it fulfills a need at a specific spot, but to get to that true dynamic environment, how are we going to accomplish that at a scale that gives you meaningful return? So I would just like to echo his comments that it's a combination of things that are going to have to be solved, but I'm not so worried about the technical part because we got really smart people on the panel here that's going to figure that out. It's more on the policy part of it and getting, you know, elected officials to actually get behind it in meaningful ways, but also private businesses and private funding that certainly is out there, and I think you've seen that to contribute to moving this forward.
Great. Dr. Hajduk or PJ would like to weigh in on that question too?
Yeah, I think I agree to Mr. Young. I think that's the way to go with. And some of the things that we need to also think about is like new innovative like ideas, like different units in which we can charge people who are using the facilities, that if they're using it dynamically charged vehicles, and also like not to put all the burden on the DOTs just to implement it once and then get away with it. So I think it has to be a trade-off between different variations in how we can make it more economical and bring in different like new kind of concepts in which we can manage both funding that is there already with DOTs, and also like bring in the money from like the users who are using facilities.
All right. The next question for the panelists, and we're going to look at PJ first. What emerging research projects and innovations are exciting to you?
I think the work that we are doing here at the Center of Aspire is moving towards the more sustainable future. So I think the overall aim of like producing something that is more sustainable, that takes into account society, environment, as well as the economics, is a very challenging task. But I think it's the way to go forward with. So I think the emerging technologies like life cycle cost analysis, life cycle analysis, and using the new concepts that like one of the ones that we are using in my projects is using more and more amount of recycled asphalt to to come up with still good designs and engineered pavements in a way that it is more sustainable. I think that's something that I'm really interested in, and that might be the stepping stone for the future, like the facilities that we are yet to build for the dynamically charged pavements here. So I think once we know what our materials are, how they behave in the field, I think it's really nice to just take that information there and then use it in a way that we can move forward with the dynamically charged infrastructure here.
And this question is open to all the panelists. So if either of you have anything to weigh in, please do. Otherwise, we can move on.
No, I agree with PJ, and I'm excited about just all the innovation that's being done. And I was on another discussion with even our team in our company, and other companies are pursuing that, certainly in the architectural and engineering fields. But, our comment was we got to move beyond, building the pavements and infrastructure bridges that we're building, and building smart pavement and smart bridges, and tying those into the work that the universities are doing, Dr. Haddock and PJ are doing as far as understanding pavements and those algorithms on how pavement degrades over time, and being able to tie that into how we're picking up that data and prioritizing how we take care of those assets and keep those assets in the life cycle of them going. I mean, right now we can have our pavements go, if we do it right, 60, 70, 80 years. We did it on the tollway when they put the pavement down in the 1960s. We're just finally repairing that. But think about how we could extend those assets even farther with smart pavements and, along with electrification of pavements. So I think we're moving into a really exciting era in, at least surface transportation, and how we can integrate all those things into that to make it a life cycle choice as far as agencies go, because funding is limited, at least from the public sector, for paying for those. And any way we can extend that through electrification and sensing and those type of things, I think is a real benefit.
Yeah, ASCE does their report card. That's about to come out again. I don't think it's come out yet this year, but I think it's about to. Pavements never rate very high. I think we're always down in that D to D minus sort of range. It's very clear that that we, at least in the U.S., have kind of ignored our transportation infrastructure problem for a while, and it needs to be addressed. And if we're going to rebuild pavements that need to be rebuilt, why would we rebuild a pavement like we did in the early 1900s, as opposed to rebuilding a pavement, to use Rick's term, a smart pavement that can do so much more and can last so much longer? And so I think that technology that's being developed is what's exciting, and that we don't have to just build a dumb pavement out there that's going to fall apart in 20 to 30 years. We can actually build something that interacts with the user. As you drive down the pavement, it interacts with you, and it'll last much longer.
Great. Well, on a similar point to what Dr. Haddock eventually mentioned, do we know to what extent will those charging equipment impact the lifespan of our pavements? I've taken pavement design with you, Dr. Haddock, and we know those characteristics and weather impact and whatnot on pavement, and we can somehow predict a lifespan for that pavement. Will we now alter that lifespan to fit with the charging technology so we can change those at the same time, or how do we have a sense of how this is going to work out?
So, at least from a loading standpoint, the chargers aren't going to affect pavement life, I don't think. And what I mean by that is simply that they'll be able to take, truck traffic loads and not have a problem. All the finite element analysis that we have done show that putting the charger in the pavement's not going to cause a problem from a mechanical standpoint. I think the question in my mind about how the charging system is going to affect the pavements is, how long will the charging system itself last, right? Are we going to have to go out in 10 years and dig something out of the pavement to repair it? Because then that puts a patch or something in our pavement, which is then more prone to failure in the future. And I don't have a very good idea of how long the charging system itself is going to last. And I'm not sure that that anybody does at this point. Maybe someone smarter than me does, but those systems are still being designed, and companies that have systems are still tweaking them. And so I'm not sure. Just from an occlusion standpoint or putting something in the pavement, though, I don't see the system doing anything to the detriment of pavement lifespan.
All right, PJ or Rick would like to weigh in on this?
Yeah, I think to add to Dr. John's point, I think one of the things that we need to think about is how we are going to analyze these pavements, I think, a bit, because these might have like very, very streamlined flow of not wandering the wheels and everything. It's going to be very straightforward how they're going to charge. So I think it might create slightly some stresses that might be very, very particular, like in some particular locations that might create some issues. And also some of the things that I was reading, I think one of the major factors is how long is this going to run, the same thing that Dr. John is talking about. And if the infrastructure runs a lot, I think the heat that is created out of it might affect the current materials that we're using. So I think the two main factors that are important here are the materials that we are using currently. Do we have to change them? Do we have to find something new? And also, like, are the existing construction practices in line with what we can do in the future? Like how we can integrate these two technologies. So I think that's something of a thought that we might have to like come up with in the future about this.
Yeah, I would just like to add to that when we were working on our project, we looked at that, as far as how can we implement this to make it sustainable, knowing that the technology that would be put into the pavement as far as electrification is going to have to be changed at some time. I don't think anybody still has a 20-year-old computer on their desk anymore. Technology changes over time. You're going to want to upgrade the tech. So how do we get to that pavement and be able to do that? So we're creating spaces in the pavement that still structurally perform, and keep those loadings and be able to take the loading from trucks and heavy traffic, but also that we can get to, and we came up with a composite pavement structure. So it's not always all asphalt or all concrete. I think it's when you're looking at designing these type of systems, how can we make it work that we can actually get back to it, but it also holds up structurally. So that was a challenge for us, certainly from the technical side. We were getting there. I think there's more work to be done as far as testing and pilot projects and seeing how that works. And, working with Dr. Haddock and his lab was on load analysis and doing all those type of things. But I would encourage people as they're going forward to think about how it's actually going to be put in the pavement, but how are you going to get back at it in the future without asking the agency to rip up the road and put it down again? Because again, we built dumb pavements that lasted nearly 60 years. We need to be able to build smart pavements that last that long without ripping the road up to get back to it.
All right. Thank you for those really good answers. The next question we have is talking about our new administration in Washington and a Secretary of Transportation who seems pretty keen on electrification. What would you like to see from US DOT going forward? And we'll start with Rick.
You know, I'm very encouraged with the administration being proactive in that space and the new secretary. I know that they were working on before these pilot programs and grants. I think they were being challenged as far as getting it into bills and getting it out there, but I do see a lot of opportunities for these corridors of the future, smart corridors, electrified corridors. I like to see them go a little bit bigger than what they had. You know, I think they're allocating, you know, several $100 million, but to be honest with you, several $100 million doesn't go as far as it used to. When you're talking about big corridors and big changes that, you know, can move the needle as far as, to John's point, you know, dynamic wireless charging and scaling and providing that whole scale benefit to 200,000 vehicles that are going by every day. You know, that's where you start moving the needle. So being able to provide those opportunities to encourage that investment, not only from the public side, the national, you know, federal side, but encouraging those public entities to get involved. And I've talked to a lot of people. I think there's a lot of private money out there that everybody gets excited around tech. Everybody wants the new shiny ball. I think we could get a lot of people around this if they know that there's investment from the public side that, you know, they're partners in this. So I'm very excited. And I'd like to see them expand those programs from not only what they're doing, but the size of them, because, you know, a couple $100 million can be eaten up by, you know, one state alone. So to get all states going, I think that it needs to be a big pie.
Thank you. PJ or Dr. Haddock, would you like to weigh in?
I don't. Nothing more to say that obviously the Secretary of Transportation is from Indiana now.
You should be able to get a lot done, man.
I've actually met him. You know, he was the mayor of South Bend. He actually spoke at road school one year. Yeah,
Oh,
nice
cool.
guy.
I think to add to that, I think something that we can see is even if we are the ones like building the new technology and everything, it has to be implemented in the field. So I think the policy decisions coming up from above, they are the ones that might pave the way for the future here.
All right, great. With that, I think we will go ahead and open the floor for the audience to ask questions. Just as a reminder, you can use the raise hand feature, and I think we already have one raised hand. So we'll go ahead and, oh, that raised hand dropped. No, here it is. Here it is. It's still there. Amal, you can go ahead and ask your question. You can unmute yourself and ask. Jackson, I think Jackson is here with us. Jackson, you can probably assist with that. Here we go.
Yep. Hey, I'm just curious to know, like the end vision or the end goal for this electrification of payments, because the EV vehicles at this point, they can go really far. So would this be very specific to, let's say, a truck lane only or something like that? Because this is going to be very costly, right, to electrify the entire road. And already the US needs to put in a lot of money for improving the existing infrastructure as it is. So it's going to be a challenge finding money to electrify that payment, I guess.
So I don't think the vision is us electrifying every road in the U.S. I think that the vision is electrification of selected corridors. And at least from a Purdue perspective, we're really working on electrification for heavy trucks. We're talking about Class 8 and Class 9 trucks. And they tend to move down the freeway around 60 to 65 miles an hour. And in order to do that, it takes a lot of power. Obviously, the faster a vehicle goes over the in-charging or the in-pavement chargers, the more power you have to be able to push through those chargers in order to charge a battery. And so, so we're looking at it just as, certain critical corridors types of things. So it's basically to try and help get rid of range anxiety for a lot of people, right? If you need to get in Indiana, for example, a huge commerce corridor is Indianapolis to Columbus, Ohio. That's I-70. If you were to drive that, you're mostly going to see semi-tractor trailers on it. It looks like, just a huge train of trucks all the time. Those are the kind of corridors that we envision, at least trying to charge in order to be able to do that. Not everything.
Thank you.
I would follow up with that as well. That I think it's select locations. We had talked to the city of Chicago, and they're like, "Well, could you do something like that for us here?" And I'm like, "Well, dynamic wireless charging may not apply, as well to downtown city of Chicago, where you're stopping every 70 feet for a stoplight, but semi-dynamic or semi-static, where you're at a stoplight, you get a charge." Bus routes, where they're going as well. But Dave Christensen and I, as we've talked to OEM manufacturers of trucking vehicles, one of their things that they pointed out, which I thought was very interesting, is, our vehicles can now go up a ramp at 60 miles an hour and merge onto traffic at speed. So it's also a traffic mixing, keeping that down where, trucks are coming up and trying to merge on at 30 miles an hour or their current power requirements. So to power up a ramp and have that charging capability and to have them come up a ramp at 60, 65 miles an hour and merge onto traffic at speed is very important. So I think to echo what Dr. Haddock was saying it's where it makes sense in locations where there's heavy traffic or where there's a need. So it's not electrifying everything everywhere, but I think applying those at specific locations is where it's going to provide the biggest benefit.
Thank you.
Yeah, I have a comment. Hello?
Yeah, we can hear you.
Oh, okay. Yeah, so my name is Mark Wayne with Tensor International, and we actually get involved with the construction of a lot of roads. The biggest thing I see from this perspective is that oftentimes we put these roads in and they have to come back in and they have to put stuff underneath the roads. So have you guys worked with people that deal with composite structures? Because I think the only way this is going to work is a composite system on the surface that can be, so say for example, a section is bad. You can pull that section out, swap in another section in, and then do your maintenance cycles that way on something that is at the surface and allow the engineers to work like our company does. We work on making sure the foundation, because you don't want to have foundation problems underneath. I happen to know that over in Europe, they have systems that are composite systems altogether where they actually combine water passage underneath as well, where you could also put cables underneath. That gets really expensive. But I mean, have you guys, my question is, have you really looked at other things that are currently out there that make that possible to swap out a surface, which I think is probably going to be the most economical thing to do, because, the DOTs are going to say, hey, we have to have access to get back in there to put a new pipe in or to run this other thing. And that way, at least you can pull that surface off and use it again and not waste the money. So that's my question.
So Mark, I can speak just to our experiences when we were working on 294 and the reconstruction of that. We're using a composite pavement. So it's a bituminous base underneath and then 11 inches of concrete and then 4 inches of bituminous on top of that. So we call it our Oreo cookie pavement. And the thing about that lended itself to electric vehicle charging was the concrete was a stable base in which we could put the charging units, the coils into, or whatever that became. and overlaying it with a bituminous surface or wearing cords. Our bituminous was lasting, the first course usually 20 years. We could probably stretch that a little bit longer, but it seemed to fit the timeline on when you might want to access the tech again. So typically you would grind off the bituminous, then you could access the tech that's in the concrete, replace that, and then overlay it again and just keep that going. We also looked at precast panels because it's constructability. So if tech failed within a panel or within a section, you could easily replace that, bring that in. So you would take off the top surface, bring in a new panel, and then put that surface back with the new tech. So we have certainly looked at that of how we can do it in mass at production.
Oh, okay, that's great. Sounds like you guys are pretty far ahead then. Good.
Yeah, I mean, whatever else we can put in there, like you said, conduits, extra conduits. I think it gets back to the smart pavement thought. I think everybody's got other ideas and great ideas, but you can only probably put so much in the pavement, and then you don't have pavement anymore, which I think Dr. Haddock and PJ would look at, well, you got to have some materials in there too. So it's a balance, certainly, but I think we need to look at it differently. And we just haven't. We put down the roads because the primary point was moving traffic. Now that's shifted to but we can also move traffic, but we could do so much more. So I think that's the focus.
I'll just make one more point that these systems don't necessarily, so if you have, 20 miles of road, it doesn't mean that there's charging in all 20 miles of it, right? There may be a mile of charging panels and then nothing for a while and then another mile. And so, one of the technology I think that would immediately be available to us is the precast concrete panels like Rick talks about, right? Where you can put those in, you have a very good foundation and basically you're snapping stuff together like, I guess I'll use the word Legos. Sorry, it's all that comes to mind, right? You're snapping things together like Legos and you can put pieces in and out like Rick says. I think that's probably technology that is probably closest to us in our that we could achieve fairly quickly. There may be other things down the road. PJ talked a little bit about, some different types of materials that we may want to develop to do this. And I think that's probably farther out, but it's certainly possible in the future.
All right, and I will go here and read a question we received in the chat box. Where do you see the future of pavement technology heading? Is there a way for pavement technology to power more than just electric vehicles? Is the future of pavement technology to empower multiple aspects involved with safe traveling, like our traffic lights? What are your thoughts? Open to all three panelists.
Yes. So I think some part of the future, I think, is probably not only using the pavements to disperse electricity to charge. I think the future lies in also using the pavements to collect electricity, meaning that the pavements are huge solar cells. If you think of all the pavements out there in the U.S., just think of all of them actually being solar, generating capability, so that when the sun shines on them, you're producing electricity. We could actually probably do that today and power some devices, like some level of street lights and some things like that. We've done some work on that at Purdue. I know there's been some work done in other places as well, in Massachusetts, University of Texas at San Antonio. I think they've got a group that's done some work on that. So I think that's part of the future as well when we talk about pavements.
Yeah, I think to add to that, we are like pavements cover a lot of part of what we have in the land, right? So I think technologies like piezoelectric materials, solar panels, solar energy, these can be harvested out of it. So I think it's just a step at a time.
Yeah, I'd like to add on to that. We are looking at resiliency along our corridors and how do you take care of that. And microgrids, I think, as people have seen in Texas, we've seen here in the Midwest, that climate is a factor in our everyday lives. And how do we be able to keep moving forward when we have these climate events. And, you know, one of it is power. How do we keep power going? And for the tollway system, no offense to anybody that uses it, but how do we keep collecting tolls? You know, because we still have to operate the system and pay for it. So the bidirectional power transfer that electrification of the roadways could afford would power those systems so that they could be self-sustaining or microgrids amongst themselves. And, you know, talking to the power people, as I think Dr. Haddock brought up at the very beginning of the discussion, was, you know, they look at it as an opportunity because it balances their load. Right now, they have an idea of how power peaks and the peaks and valleys of it because of how people use power at their homes or businesses. But with a new dynamic that we're all facing, is that going to be the same or is that going to be changing? It's probably going to be changing. And if they can predict through traffic where power needs are going to be, that helps them balance their load requirements and what power they have to deliver. So they see it as a real benefit as well to move towards vehicle electrification and charging opportunities.
All right, great. Do we have any more questions from the audience? Remember, you can use the raise hand feature or you can type in the chat box.
I have a question.
Go ahead.
Yeah. Have you seen this being adopted in other countries? So I would think like Norway would come to mind as a place that might consider it, just because they have such widely adopted electrical vehicle use.
There's a company right now called Electrion that's working with Aspire. Been out to the conferences certainly, and I think has a pilot program going on there that Dr. Christensen's working on with them. But they have deployed a full-scale pilot project in Sweden. They're working on one in Germany, one in Tel Aviv, and there's one in Italy for buses and heavy vehicles. They've been doing dynamic wireless charging, mostly in bituminous pavements. They're looking at how they can implement it in concrete pavements, and that's how they've got Inspire involved and others involved in what are those dynamics, no pun intended, that is a difference in material types, and you know, it reacts with bituminous material differently than it reacts with concrete, and what kind of materials, as PJ talked about, how can we construct our pavements that can take those things, because we're putting other things in the pavement that are dynamic and not just static. Long-winded answer to your question.
Thanks.
All right, anyone else from the audience?
Looks like
there's
we
a
have
question in
chat.
There was something in the chat box.
Okay, I apologize, I did not notice that. In your opinion, what has to come first? A rise in AV users to really kickstart the transition of transportation infrastructure to this new technology, or the infrastructure in place to push consumers to purchase AVs?
Personally, I think we're headed towards electric vehicles. In California, I think it's after 2030 maybe, or 2035. You can't sell. You can't sell. You have to sell electric cars in California. I can't remember that date. Rick may know. He's shaking his head like he's heard that. You know, the Ford Motor Company, for example, is working on an electric version of the F-150, which is the best-selling truck in America. I personally am waiting for the electric F-150 to buy my electric car, because that's what I want. I think we're headed that way. It may not seem that way, and that's my personal opinion, is that electric vehicles are coming, and we have to try and gear up to get ready for those somehow. The technology is going to continue to get better and better. Right. I mean, Tesla pushed the envelope, and it's pretty good now, but it'll get better.
I think consumers will affect change. I think you're about right, but more importantly, if you look at the OEM manufacturers of car companies, they're starting to put a line in the sand that they will no longer sell internal combustion engine vehicles after a certain date. And some of them are pretty close. Some of them have said 2025. So, you know, the consumers will have less choices as the years come along. And I think they're going to drive the change in where electrification occurs. We've done studies with Aspire, Select, and looking at demand. And is everybody going to go to a place and plug in and wait 20 minutes for their car to charge? Well, that's great if nobody's also waiting or getting their car charged. So there's going to have to be solutions developed that is a suite of solutions. It's not going to be just dynamic or just static that charges people's vehicles. It depends on their situation. So I think a whole host of opportunities to charge are going to come out of this, and it's going to be driven by consumer demand.
PJ, would you like to weigh in on that?
I think that's good. I think I think it's the same. The EV adoption is going to grow faster. It's going to be exponential, and to cope up with that, we need to build the physical infrastructure and be ahead of the game, so that both the technologies can go hand in hand. And when we have actually like a lot of EVs on the road, we don't look up for infrastructure there. We already have it. So I think both the technologies are going hand in hand, and it's a good future in front of us.
Great, thank you. I'll have your final call for the I see Ariana's hand raised. So Ariana, please unmute and ask your question.
Thank you. Can any of you guys share any estimates that you have for the additional cost of implementing this EV technology? And specifically, are those costs coming from additional labor, or is it more so materials?
Rick may have the best idea about what he thinks additional costs are, because he's probably worked with it longest.
It depends on what type of facility you're talking about. You know, an expressway isn't cheap these days. So our benefit was we were going to be putting in the pavement anyway, so it's an added value cost. You know, it was certainly like anything, like a phone, if you're buying a new one or those type of things, the cost is very high because you're a leader in that. There's not a lot of product out there, so the cost is higher, but as it gets more mature, the cost comes down. That's kind of economics 101. So it's hard to say what the ultimate cost would be, but you know what the implementation cost is. You know, to include all the infrastructure, it's probably several $1 million per mile. It depends on if you have power readily available. We were looking at, through associations with Aspire and other people, about using renewables, wind and solar along our rural areas, that we have systems to power those. So it depends. There's not a specific answer yet. I don't think there's been enough projects and enough maturity to start having those go-bys that, okay, if you want to start estimating a project, you need to include, you know, this X factor to include electrification. We just don't have those go-bys yet. It's more of us calculating it out and saying how much is it going to cost for labor and materials. And the pilot project we were going to do was going to be around $10 million for a mile of pilot to include that, but that included getting power to it and putting the receivers on the vehicles and putting the coils in the pavement.
All right, we have one more question in the chat box that we received. How do you think electrical and civil engineers can assist one another to head in the desired direction?
Well, I can tackle that one, and John and PJ can weigh in, but I just was talking to somebody before this about, you know, I think for at least engineers in school and coming out to be more multidisciplined, I've seen that in my career and what we do. is that, you know, you have to be aware of all the other disciplines, not only what you're doing as you move on in your career. You know, you have to be aware of structures, environmental, water, electrical, those type of things. And likewise, electrical engineers, you know, they used to be more in just the power side and those type of things. And it's these spaces are converging and overlapping. And I think, you know, it's to anybody's benefit to learn more about it. You don't have to be necessarily a master, but we have a lot of really smart people that do live in those spaces and assist, you know, in those areas. But for the rest of us that just got our bachelor's degrees and ended it there, you know, we have to be able to cross those different spaces and actually be able to work in those two different environments. So it's converging, definitely.
You may be advocating for civil engineers to take some electrical engineering courses while they're in college.
I didn't say that because I took electrical engineering and it definitely put me in the civil engineering path because I barely passed Circuits 101, so I checked out. But
Yes, I had circuit analysis as well as an undergraduate, and it has given me enough of a background to sort of understand what the electrical engineers tell me when I talk to them. But it has been a lot of fun to work with electrical engineers, to work with somebody out of the space that I work in every day. And I hope that they would say the same thing, that they have enjoyed working with civil engineers to try and solve some of these problems jointly. It has been, I think, largely due to Aspire and the work that that group has done has been a lot of fun to try and put all these people together and try and solve these problems that need to be solved ahead of doing this. So I would also advocate for perhaps a bit broader education as an engineer, as opposed to being so focused on one little thing. That you can only see, this the inch in front of you, as opposed to having a broad vision of what needs to happen. I think that when you go out into industry and begin to work, that's when you start to see that how important that vision, that broad vision of everything is, rather than just the little tiny things that we taught you in college.
Great. With that, I think we will close out here with the audience questions, and we'll have a final question for all three panelists, in which we will also ask you to have some final remarks after you answer that question. So we're going to ask all three panelists, what are the biggest open research questions out there, and what do we not know yet? Pretty open, broad question. Would like all three, and I'll name Dr. Heddick to begin here.
Yeah, thanks for choosing me first. This is like the speed round or something.
Yeah.
So I think probably the biggest thing we don't know is what we don't know, right? It's what you don't know that you don't know that jumps up and gets you in the end. And that's probably, I think, the thing that keeps us up at night more than anything else. I think we have a pretty good handle on a lot of the technology, or the technology that needs to be developed and how it goes together. But I think, Rick has already talked today about some just the policy types of things and, financing types of things. Those are things that I don't really deal with so much. Those are the kinds of things that we may not know what, needs to happen yet. And those are the things that I think are going to be the biggest issues that we probably face.
I would have to follow up with that on, and Dr. Christensen was, she's got a front row seat to this, but it's, how do we move it from the lab out into the real world? And I would give presentations on that, saying it's time to, go live in the real world, because that's where you're going to find out a lot of your answers to a lot of your questions. And certainly the lab work has to be done, but when you get to a certain maturity point, you have to take it out in the field. And how does it work in 18 inches of snow in Chicago when it's 3 degrees out? How does it work in Texas when they, get sub-zero weather? Those things you can model. We got great computers, but until you get out there, And the big X factor is people. How are people going to react to their vehicle being charged? How are they going to interact with that environment? That's the big unknown. We're all thinking that everybody's going to love it and want it, but there's going to be people that don't. So, you know, getting out into the real world is your biggest laboratory that you can have. And, you know, I think that's the big unknown. And I think to Dr. Haddock's point, we don't know what we don't know, but we need to get out there and find out what those unknowns are so we can solve those.
Yeah, I think to add to that, or whatever Dr. John tells, I think the technology that is coming up is coming up really fast in EV development, and we don't know what's coming up with there, and we have to cope up with that, and we have to also work with different different stakeholders here, whether it be industry, the government, the people who are actually manufacturing these units, and we have to bring all together. It's not only just our like the infrastructure unit that is going to work in this one. We have to work hand in hand with all the different stakeholders, and I think that's going to create like more and more how can I put it, like questions in front of us, like, hey, we did not think about this, we did not think about this. So I think once we bring up into that implementation phase, that's when things are going to get interesting, and we will get some answers to it.
All right, well, great answers from all three panelists. With that, I think we can conclude this. On behalf of the Purdue ITE chapter and the Aspire Student Association, I would like to thank all three panelists for their participation today. This was informative, great, and we look forward to future collaboration as well. So thank you to all three of you, and thank you to the audience as well.
Boiler up.
Boiler up.
Hammer down.
I'll let that slide.
Bye.
Thanks a lot, everyone.
Good night.